In this video, we'll be discussing dimensional analysis, which is a tool that is used time and again in the sciences. Not only Gen Chem students use dimensional analysis, but practicing scientists often make frequent use of it. As stated, dimensional analysis is an extremely useful tool. It can be almost thought of as a machine that you feed units into and it spits out the correct answer. It allows for a systematic way in which to solve problems. Furthermore, it also provides an internal check on a problem to make sure you've achieved the right answer. Dimensional analysis takes advantage of the fact that units are inherently linked to the quantities being examined. By keeping track of these quantities throughout a problem, one can be led to the correct solution to that problem. Dimensional analysis often involves multiplication and division, wherein quantities are combined or canceled out. These often involve the use of conversion factors to convert from one set of units to another set of units. Conversion factors are simply ratios or fractions that relate two equal quantities to one another that happen to be in different units. The easiest way to explain dimensional analysis is to simply go through some problems. So we're going to go through 3 problems that get progressively more and more difficult. In the first problem, we're going to do a conversion between one unit of weight and another unit of weight. So we're going to take the average weight of an Irish Wolfhound in pounds and convert that into stones, with 1 stone equaling 14 pounds. So the problem is fairly simple. We just need to convert from pounds to stones, but we need a method in order to do this. And the way which we do this is we apply a conversion factor. Here, the conversion factor relates stones to pounds. 1 stone equals 14 pounds, or the ratio is 1 stone to 14 pounds. If we take our 110-pound average female Irish Wolfhound and multiply that through by our conversion factor, what will happen is the pounds will cancel out. Multiplying through, we have it in the numerator in the pounds and in the denominator in the conversion factor, leaving us with just stones, which is the unit that we want. We now have 110 stones divided by 14, which gives us 7.857 stones. If we consider the number of significant figures in this problem, it only has 2. So, following rounding, we get 7.9 stones. In the second problem, we're going to be going through a slightly more complex problem because this will involve multiple conversion factors. So what we're going to do is we're going to determine the distance from the Earth to the Sun in a unit called hands, which is a length unit used nowadays to measure horse height. So what we want to do is we want to take the distance from the Earth to the Sun in kilometers and convert that to this distance in hands. In the problem, we're given information to do the conversion factor. 1 hand equals 0.102 meters. But what we have in the problem is the distance from the Earth to the Sun given in kilometers. So we need a conversion factor from kilometers to meters and then meters to hands. So sketching this out, we're going to take our distance in kilometers, a conversion factor to meters, a conversion factor from meters to hands, and then finally the distance in hands. Going through, by definition, 1 times 10 to the 3 meters equals 1 kilometer. 1 hand equals 0.102 meters. Plugging in the distance from the Earth to the Sun in kilometers, what we'll have is our kilometers canceling, we'll have our meters canceling, and we're left with hands. Multiplying these 3 through, we get 1.496 times 10 to the 11 hands, divided by 0.102. Going through and doing the arithmetic, we get 1.466 times 10 to the 12 hands. Considering the number of significant figures, we end up with 1.47 times 10 to the 12 hands, because we have 1.00 hands equaling 0.102 meters, which has 3 significant figures. Those are the least number of significant figures in the problem. Therefore, the answer has to have 3 significant figures. The last problem is even more complex in that we have to take 2 conversion factors and then convert from one quantity into a different quantity. So what we need to do is we need to take a speed of a car traveling at 65 miles per hour and turn that into the time it traveled in 82 kilometers in terms of seconds. So we need a conversion factor to go from miles to kilometers. We need another conversion factor to go from hours to seconds. And then we need a way of going from a rate and a distance to a time. And we're going to use dimensional analysis to accomplish all of this. The first thing we're going to do is we're going to convert from miles per hour to kilometers per second. The second thing that we're going to do is we're going to use the speed in kilometers per second, the distance traveled, 82 kilometers, and get the time that it took to go that distance in seconds. So starting with 65 miles per hour, if we multiply that through with a conversion factor that changes us from kilometers to miles, what will happen is the miles cancels out, and then we'll be left with kilometers per hour in the final answer. So we need the second conversion factor, hours converting into seconds. There's 3,600 seconds per hour. Canceling these out, we're left with kilometers per second, which is exactly what we want. So here, the dimensional analysis shows that by doing these conversions, we're going to get our final answer in the terms of the units that we need. And that turns out to be 0.0291 kilometers per second. We can now take that speed and that distance and convert that into the time it takes to travel that distance. The speed has kilometers in the numerator. The answer, time traveled in seconds, needs to have seconds in the numerator. Therefore, we need to take this quantity and take its inverse. This would give us 1 second per 0.0291 kilometers. Multiplication through by 82 kilometers will cancel out the kilometers, leaving us only with seconds, and give us the answer of 2,800 seconds. Notice we have 2 significant figures in the answer, and all of the input values that we used in the problem have 2 significant figures. And with that, we've reached the end of this video. The key takeaway from this video is that dimensional analysis provides you with a method to let unit cancellation and combinations walk you through a problem. It helps you get through the problem, and it also provides a check to make sure you did the problem correctly. In the next video, we'll learn a strategy for systematically going through and solving problems in general chemistry.